Alright guys, welcome back. So in this video, we will start with a new chapter. Okay, so this is your Form 5, Chapter 3. Okay, so this chapter is called Thermochemistry. So normally in the first lesson of a new chapter, I will go very slow. Okay, because you need to master some of the important concept. Okay, before we can continue with other lessons. Okay, all right. So this chapter is called Thermochemistry. Okay, this chapter Form 5, Chapter 3. This chapter is called Thermochemistry. So actually, what is thermochemistry? So thermochemistry can be split into two words. The first word is called thermo. Thermo is something related with heat. Thermo is something related with heat, something related with temperature. That's why we have thermometer. Okay, we have thermometer. So thermo means heat. So chemistry, same lah, chemistry. So this chapter we will focus on heat and chemistry. So in this chapter we will focus on the relationship between heat and also chemistry. Okay, so let's start. Okay, so there are a few important concepts that we need to learn for today lesson. So this lesson is called Introduction to Thermochemistry. Okay, in today's lesson we will learn all the basic idea, okay, all the basic concept for thermochemistry. Okay, so let's start with the first concept. Okay, so you need to understand that all chemical reactions involve heat. All the chemical reaction we always involve heat. Okay, heat, they can be absorbed or they can be released. Okay, so what do I mean? All the chemical reaction, they need to absorb the heat or they need to release the heat. That's it. Okay, chemical reaction, they must absorb the heat or they must release the heat. Okay, all right, you cannot say I have a chemical reaction, this chemical reaction do not absorb the heat, do not release the heat. Cannot. All the chemical reaction, they must involve the heat. Okay, so the heat can be absorbed, the heat can be released. Okay, so next one. So we have two types of chemical reactions according to heat. Okay, so if we want to use the heat to classify the chemical reaction, we have two types. The first one is called endothermic reaction. The second one is called exothermic reaction. So what is endothermic reaction? Endothermic reaction, okay, so how to memorize here? Endothermic, okay, endothermic, look at the word en, en. So the word en, endo, en means enter, okay, the word en same as enter. So endothermic reaction, the heat enter means goes in, the heat goes in. Okay, so when the heat goes in means absorb heat. So any chemical reaction that absorb the heat, we call it as endothermic. Okay, any chemical reaction that absorbing the heat, we call it as endothermic reaction. Okay, what about another one? Exothermic reaction. What is the keyword here? Exothermic, EX. EX, we call it as exit. You look at it, exit, you have EX, right? Okay, exit. Exit means what? The heat goes out. The heat goes out. Okay, so exothermic, the heat goes out. Heat goes out means what? Release the heat. Okay, so that's it. So any chemical reaction that releasing the heat, okay, it is exothermic. Okay, so that is what you need to know. Okay, all right. So I hope you can understand this simple idea. So let me show you an example here. Okay, so this is a chemical substance. If this chemical substance absorb the heat from surrounding, the heat, you go and absorb, you take in the heat. So when the heat go in, so go in is endothermic. Okay, when the heat go in is endothermic. How to know endothermic? Enter. Okay, enter. The heat enter the chemical substance. Okay, that is endothermic. So another one, what about this? If this chemical substance, okay, if this chemical substance release the heat, if the heat go out, so the heat go out from the chemical substance. If the heat go out, so go out means exit. So exit, EX, exothermic. Okay, so that's it. Okay, so any chemical reaction that absorbing the heat, it is endothermic. Any chemical reaction that release the heat, it is exothermic reaction. Okay, so I hope you can see the difference. Okay, I hope you guys can see the difference between endothermic and exothermic reaction. Okay, so the next thing, you must know the relationship between, okay, endothermic, exothermic, and also temperature. Okay, so you must know how the temperature change in the endothermic reaction and how the temperature change for the exothermic reaction. Okay, so that is what you need to know. Okay, all right, so now let us start with the endothermic. Okay, we will start with endothermic reaction first. Okay, so we will start with endothermic reaction. So endothermic reaction will absorb the heat. Endothermic reaction will absorb the heat from surrounding. Okay, all right, so we will absorb the heat from surrounding. Okay, what do we mean by surrounding? Okay, so in this chapter, the surrounding is referred to solution. I repeat, in this chapter, all the surrounding is referred to the solution. Okay, so endothermic reaction means, okay, the chemical substance will absorb the heat from the solution. Okay, so let me show you. Okay, so imagine this. Okay, all right, so this is the chemical substance. Okay, this is the chemical substance. All right, so and then this is the surrounding. Surrounding is the solution. Okay, so just assume, no need to memorize, guys, no need to memorize. Just assume initially, the surrounding has 100 joule energy. Just imagine, initially the surrounding, the energy is 100 joule. Okay, so now if this is endothermic reaction, endo, en stand for enter. So now the heat will enter the chemical substance. So this is chemical substance. So this chemical substance will absorb the heat from the surrounding. Okay, so look at it. So this is the surrounding. So the energy absorbed by the chemical substance. So the chemical substance absorb the heat from the surrounding. Okay, so that is what happened. Okay, so as you can see in this picture. Okay, so all the heat from the surrounding, okay, all the heat from the surrounding, all will go into the chemical substance. Okay, so when the heat go into the chemical substance, okay, so the surrounding energy now should become lesser. The energy surrounding should become lesser. Correct, right? Imagine initially outside here have 100 joule. So if this chemical substance absorb 60 joule, just assume, so 60 joule go into the particle. So outside here left how many? 100 joule, 60 joule of energy absorbed by the chemical substance. So 100 minus 60 still left 40. Okay, that's what you need to know. Okay, all right, so some students say, sir, do we need to memorize the number 40? Do we need to memorize the number 100? No need. No need. You just need to understand the concept. Yeah, you just need to understand the concept only. Yeah, so the chemical substance absorb the heat from the surrounding. So when the heat is absorbed from the surrounding now has less energy. Okay, so that's it. Okay, the surrounding has less energy. Okay, because all the energy go into the chemical substance already. Okay, so now what about the temperature? So if you put a thermometer, so this is a thermometer. So if you put the thermometer here, so what you expect you can see. What you expect you can see. So you see initially when you have 100 joule, so now you become 40 joule only. So when 100 joule become 40 joule means what? The surrounding have less energy, right? The surrounding now have less energy. So when the surrounding have less energy, so the surrounding the temperature will go down. Okay, surrounding have less energy, surrounding have lower temperature. That's it. Okay, so a simple concept. More energy, temperature increase. Less energy, temperature decrease. Okay, so the energy from the surrounding is absorbed by the particle. So this particle absorb the surrounding heat. So when the heat of the surrounding is absorbed, so now the surrounding have less energy. When surrounding has less energy, temperature will decrease. Temperature will decrease. Okay, so that's it. So this is the concept that you need to know. Okay, when the chemical reaction absorb the heat from the surrounding, so now you can see the solution lose energy, correct, right? Okay, so the surrounding is the solution. When the energy of the solution is absorbed, so now the solution lose energy. So you can see now the solution have less energy. So when the solution have less energy, the temperature of the solution will drop. Okay, the temperature of the solution will drop. Okay, so this is what you need to know. It's not very hard, it's not very complicated, right? Okay, so that's it. So let's try another one more example. Okay, look at it. Okay, what about exothermic reaction? So exothermic reaction is the chemical reaction that will release the heat to the surrounding. Okay, they will release the heat to the surrounding. Okay, so remember this, no matter you want to absorb the heat or you want to release the heat, you must always get it from surrounding. Okay, and what is the surrounding? The surrounding is the solution. Okay, so now exothermic, ex is exit, so the heat exit, the heat go out, so go out means release. Okay, so exothermic reaction, they will release the heat to the surrounding. So what happened? So look at these three picture. So again, this is the chemical substance and this is the heat in the surrounding. Just imagine initially the surrounding, the energy is 100 joule. Okay, so now exothermic, the heat will release to surrounding. So you see this particle, the heat will release. Release means let go. So you let go the heat, you put the heat, you put the heat, you put the heat. Okay, so now you release the heat to the surrounding. So when you give the heat to the surrounding, okay, when the heat go to the surrounding, now the surrounding should have more and more energy, right? Okay, now the surrounding should have more and more energy. Okay, just imagine this. Surrounding is 100 joule. This is your chemical substance. So when the chemical substance release the heat to surrounding, let's say the chemical substance release 40 joule to the surrounding. So 40 joule go into the surrounding. So 100 plus 40 joule, surrounding now is 140 joule. Okay, so that's it. Okay, so when you release the energy to surrounding, surrounding will have more and more energy. When you absorb the heat from the surrounding, surrounding should have less and less energy. Very simple one. Okay, so same thing, all the number here no need to memorize. So when you put in a thermometer, okay, what you expect you can see. Okay, what you expect you can see. So look at it. When the chemical reaction release the heat to the surrounding, so now the surrounding, which is the solution, okay, will gain energy. Okay, the surrounding will get more and more energy, right? Okay, so from 100 now become 130. So when the surrounding got more energy, what happened to temperature, everyone? More energy, the temperature will increase. So the temperature will increase. Okay, so that's it. All right, so this is what you need to know. Okay, this is a very important concept that you must understand. Okay, all right, so now let me give you a summary one more time before we do some exercise together. Okay, all right, so what is this? Okay, so endothermic reaction. Endothermic, enter the heat, enter the heat, go in to the chemical substance. When the heat go in means what? Absorb the heat. So endothermic reaction, you absorb the heat from where? From the surrounding. So when we absorb the heat from surrounding, so surrounding now have less energy. So you have less energy at the surrounding. When the surrounding has less energy, so the temperature of the surrounding decrease. That's it. Okay, so terbalik, if we have exothermic, EX exit. So when the heat is exit means release. You release the heat. So when we release the heat to the surrounding, okay, so when we release the heat to the surrounding, now the surrounding should have more energy. So when surrounding has more energy, temperature will increase. That's it. Okay, so it's not a very hard concept, but you need to see the difference, okay, because many students, they are very confused on this concept. It's not very hard, but there's so many students are very confused about this. Yeah, all right, so that's what we need to know. Okay, all right, so now let me show you a sample question. So I'll show you a sample question that we will do together. Okay, so we have two pictures here. So you see, initially we put sodium hydroxide, which is an alkali, and hydrochloric acid, which is an acid. So we put the alkali and we put the acid together. Okay, we mix the acid and we mix the alkali together. And this is a thermometer. This is thermometer. So initially the temperature is 25. Okay, so when we mix the two solution, the temperature is 25 degrees Celsius. After we mix these two solution, now the temperature becomes 70. So what happened here? So temperature from 25 to become 70, temperature increases. From 25 to 70, temperature increases. So when temperature increases, what it is? Based on the temperature change, tell me the type of reaction. Okay, so when you look at the temperature change, you only can have two possible answer, which is endothermic or exothermic. Okay, if you look at the temperature, you should able to know it is endothermic or exothermic reaction. Okay, so which one it is? Okay, so remember the concept. So in exothermic reaction, okay, okay, the temperature will increase. So when you see temperature increases, it is exo. Why? When the particle, okay, let's say this is hydrochloric acid and this is sodium hydroxide. So when they react, so they release the heat to the surrounding. So when they release the heat to surrounding, so the surrounding here has more heat, right? When they release the heat to surrounding have more heat. So when you put a thermometer, when you have more heat, what happened to the temperature? The temperature will increase. Okay, so when temperature increases, so this is exothermic reaction. Okay, so this is exothermic reaction. So that's it. Okay, so make sure you know how to relate temperature and also endo and exo. Yeah, okay, right. So final summary one more time. So when you see temperature increase, it is exothermic. When you see temperature decrease, it is endothermic. Okay, all right, so that is what you need to know. Okay. Okay, so now we are done with this. Okay, we are done with this question. Okay, so some student will say, sir, this is sodium hydroxide, alkali. This is hydrochloric acid. So I learned before, acid plus alkali will produce salt and water. So acid react with alkali will produce salt and water. So when they produce salt and water, sir, can I call this reaction as neutralization? Can I call it as neutralization? The answer is cannot, because the question asks you to tell them what is the reaction based on temperature change. Okay, if they never mention the temperature change, okay, if they only say what is the type of reaction, then okay, you can write neutralization. But when they want you to tell them what is the reaction based on temperature, okay, whether the temperature increase or whether the temperature decrease, then your answer must be endothermic or exothermic. That's it. Okay, this is what you need to know. All right, so now, okay, after we covered this question, so now let's continue a little bit more. Okay, so here are some of the examples for endothermic and also exothermic reaction. Okay, here are some of the example for endothermic reaction and exothermic reaction. Okay, so let me go through it with you first. Endothermic reaction, we have photosynthesis. Okay, we have photosynthesis, okay, which is true, right? Photosynthesis, the plant need to absorb the heat from the sunlight. Okay, in photosynthesis, the plant need to absorb, okay, the heat energy from the sunlight to produce the food, which is glucose. Okay, that's it. So photosynthesis is endothermic. Okay, so dissolve the nitrate salt. When you have nitrate salt, okay, for example, when you have a sodium nitrate, you want to dissolve it, you put it in water. Okay, when you want to dissolve the sodium nitrate, you need to put in water. So when you dissolve the nitrate salt, it is endothermic. Okay, next one, dissolve ammonium salt. Okay, when you dissolve ammonium salt, it is endothermic. What is ammonium salt? Ammonium is anything has NH4. Anything has NH4 is ammonium salt. Example, NH4Cl. Okay, so this is ammonium salt. So when you put the ammonium salt into water to dissolve it, it is endothermic. Okay, that's it. All right. So the next one is, all right, decomposition of carbonate and also nitrate. Okay, decomposition of carbonate and also nitrate. Okay, what do we mean by decomposition? Decomposition is a concept that you learn in your Form 4 Chapter 6. Okay, so what is decomposition? Decomposition means you want to break the compound by heat. You use the heat to break down a chemical substance. Okay, you use the heat to break down a chemical substance like this. This is a chemical substance. You use the heat to break it down. So this process is called decomposition. Okay, so for your level in SPM, you only need to know the decomposition of carbonate and nitrate. Okay, what is carbonate? Carbonate is anything ended with CO3. Anything ended with CO3 is called carbonate. Example, CuCO3. This is a carbonate. Yeah. So nitrate is what? Nitrate is anything ended with NO3. Okay, anything ended with NO3. So which is nitrate. Okay. So when you decompose the carbonate like this, when you break down the carbonate, you will produce oxide and carbon dioxide. Okay, you will produce a metal oxide and carbon dioxide. So you learn this in your Form 4 Chapter 6. Example, copper carbonate. Okay, after you break it down, it will form copper oxide and carbon dioxide. Okay, so this is called decomposition. Okay, decomposition. Okay, so decomposition is endothermic. It will absorb the heat. Okay, all right, so that's what you need to know. Okay, that's what you need to know. Decomposition, okay, it's always endothermic. Okay, the last one is all the chemical reaction that involve hydrogen carbonate, okay, is actually endothermic. Okay, what is hydrogen carbonate? Hydrogen carbonate is anything has HCO3. Anything has HCO3 is called hydrogen carbonate. Okay, so these examples are endothermic. Okay, do you have many other example? Yes, we still have other, but not important. Okay, these are the 5 important examples that you need to know. Okay, exothermic reaction, we have a lot: combustion, respiration, oxidation, double decomposition, dilution, rusting, and many more. Okay, all right. So now the question is that should you memorize all these example? All right, so you have a choice whether you want to memorize or not. Okay, this one normally where they ask the question, this one normally the question is being tested in objective. Normally they will ask you this question in objective only. Okay, so you can memorize, but I think it doesn't worth it. Imagine you memorize so many example just for 1 mark, just to get 1 mark, okay, for your objective question. So I think that is, you don't need to do that lah. Okay, You memorize so many things just for 1 mark. That's it. So if you don't know what is the example of endo, or you don't know what is the example for exo, is okay. You will just lose 1 mark in your paper. That's it. Yeah? Alright. But if you really want to memorize, you don't need to memorize more. You don't need to memorize all. Okay? So this is the tips for you. If you want to memorize, there are too many examples for exothermic reaction. Okay? Exothermic, you can see the examples so many. Okay? I would say more than 90% of the chemical reaction that we learn in SPM, they are all exo. I repeat, more than 90% of the chemical reactions that we learn in SPM, they are exo. So exo, we have many examples. So you don't need to memorize. We just need to know the example for endothermic. Okay? You just need to memorize the example for endothermic, which is these 5. Okay? Photosynthesis, dissolve nitrate and ammonium, okay, decomposition, and hydrogen carbonate. That's what you need to know. Okay, all right, so I teach you how to memorize. So the first one is photosynthesis. So the second one is when you want to dissolve nitrate and you want to dissolve ammonium. Okay, number 3, decomposition. Decomposition means you want to break down the chemical substance by heat. Number 4 is hydrogen carbonate. Okay, so these are the examples for the endothermic that you need to memorize if you want to memorize. Okay, you can choose whether you want to memorize or not. Yeah, so if you want to memorize, only memorize this. So all the other example which is not here, they are exo. Okay, all other example not here, they are exo. For example, rusting. Rusting is not inside here, so it's exo. For example, combustion. Combustion means burning. Combustion is not inside here, so it's exo. Okay, so this is a simpler way to memorize. Okay, you just memorize the endo. Okay, and then anything not in the endothermic, they are exo. Simple as that. Yeah. All right, because there are too many examples for exothermic. It's very hard if you want to memorize all the exothermic reaction. Okay, so don't do that. Yeah. All right, so now I'll show you an example so that you have a better idea, okay, how the question can be tested. Okay, I'll give you an example so you can imagine how the question can be tested in your SPM. Okay, so the question is this. Okay, all right, so this is a sample question. All right, so this is one of the trial exam question. Okay, so and then you can expect they will ask a question like this. So I say just now, if they want to ask you endo and exothermic example, okay, if they want to ask you the example for endothermic and exothermic, they always ask you in objective question. Okay, they always ask you in objective A, B, C, D. Yeah. So let's look at this question. Which of the following is exothermic reaction? Okay, which of the following here is exothermic reaction? Okay, did I ask you to memorize any example for exo? Did I ask you to memorize any example for exo? No, right? I said we have too many examples for exo, so we just need to memorize the example for endo. That's it. Okay, so now, so we never memorize what are the exothermic reactions. So what to do? We need to find out what is endo. That's it. So combustion. Is combustion the exothermic or endothermic? Let's see. So what are the endothermic reaction that I teach you? So the first one is photosynthesis. Photosynthesis is endo. The second one is you can dissolve nitrate or you can dissolve ammonium. Okay, you can dissolve nitrate or ammonium. Okay, the third one is this. Okay, the third reaction is decomposition. Okay, decomposition. And the last one is hydrogen carbonate. Any reaction that involve hydrogen carbonate, that is endo. Okay, so you only need to memorize these 4. Okay, so anything not in these 4, they are exo. So look at combustion. Is combustion in these 4? No, combustion is not in these 4, so it is exothermic. So look at B, decomposition of magnesium carbonate. Decomposition it is inside the 4 thing here, so it is endothermic. Okay, dissolve zinc nitrate in water. So when you dissolve nitrate, it is endothermic. Last one, photosynthesis. Photosynthesis is endo. Yeah, so that's it. Okay, all right. So that is what you need to know. Okay, so that is what you need to know. Okay, so you see, so we didn't memorize which example is exo, but we know the answer B, C, and D, they are endo. So we cut out the endothermic. So now we know that combustion will be exothermic. Okay, so this is how you do the objective question by elimination. Okay, so any answer which is wrong, you cut it out. Okay, like this one, you know, decomposition, this is exo, so this is endo, out. Dissolve the nitrate, this is endo, out. Okay, photosynthesis, this is endo, out. Okay, so the best answer is A. So this is how we solve the question. Yeah, step by step. Okay, so remember, so you have the option. If you don't want to memorize endothermic or exothermic example, is okay, because you only lose 1 mark. That's all. You only lose maximum 1 mark. That's all. Yeah, but if you want to memorize, only memorize the example for endo, because endothermic you only need to memorize 4 things only. Yeah, you only memorize 4 things. Okay, exothermic maybe you have 15, you need to memorize, too many already. Yeah, so learn in a smart way. Memorize 4 better than memorize 15. Okay, so that is how you memorize. Okay, but again, like what I say, if you don't want to memorize, it's okay. Yeah, you just lose 1 mark, it's okay. Yeah, as long as you can score the other part, this 1 mark is still okay. Yeah, not a big problem. Okay, not a very big problem. Okay, all right. So next one, now we need to know what are the applications of endothermic and what are the application of exothermic reaction. Okay, what is the application for endo and what is the application for exothermic? Okay, so we need to know hot pack and cold pack. Okay, hot pack and cold pack. So hot pack, okay, is a special bag. Okay, is a special bag. Okay, that when we go to squeeze it, okay, when you tekan it, when you squeeze the bag, so the bag will become hot. That's it. Okay, so like when you put your hand, you tekan it. Okay, when you just tekan it, so then you can see that the bag will become hot. Yeah, so cold pack, the other way around. Cold pack, when you go to, okay, when you go to like you squeeze, when you squeeze the bag, so the bag will become cold. So that is hot pack and cold pack. All right, so okay, what are the use of hot pack and cold pack? Let me give you some example. Okay, hot pack is something like this. Okay, let's say you go to the country that currently have a cold climax. Okay, let's say the country currently got snow, okay, which is very cold. Okay, it's very cold, so you can put the hot pack. Okay, you can put a hot pack. Okay, all right, inside the shirt. So when you put the hot pack in the shirt, so your body will feel warm. You feel warm. All right, so that is the use of hot pack. So cold pack is what? Cold pack, let's say, okay, there is a person, this person fall down, then the hand swollen, the hand bengkak, swollen. So you can put a cold pack. When you put a cold pack, okay, so when you put a cold pack, so on the swollen part, okay, the bengkak part, you put something cold, so the bengkak part, okay, now it will become better. You won't feel so much pain. All right, you won't feel so much pain. All right, just like maybe if any one of you play sport, okay, let's say your hand got injured, so your hand got bengkak. So normally what they do, okay, they will put some ice. They will put some ice on the swollen part. So when they put the ice on the swollen part, on the part which is bengkak, you don't feel so much pain. You feel better. Yeah, so that is cold pack. Okay, so you need to know what is the raw material inside the hot pack and what is the raw material inside the cold pack. Yeah? In the hot pack, we always put in a chemical substance called magnesium sulfate. This one, if you don't memorize, is okay. If you don't know, never mind. Okay, because in SPM for the past 20 years, okay, for the past 20 years, they only ask the hot pack for 2 times. They only ask 2 times, okay, out of 20 years. Okay, so it's not really important. Okay, now cold pack, this one must know. Okay, cold pack, put 5 star here. This one must know. This is a very, very popular question. This is a very popular question. Okay, in the past 20 years, this question asked about 10 times already. Okay, about 10 times already. This is a very, very popular question. Okay, so cold pack inside is made of ammonium nitrate. Okay, cold pack is made of ammonium nitrate. You must know this. And makes sense, okay, it makes sense, all right. Let me share some idea with you. In the cold pack, they have 2 things. Okay, one is water, one is ammonium nitrate. Okay, so when we try to squeeze, when you put the hand to squeeze, okay, when you tekan the cold pack, so inside here the ammonium nitrate and water will mix together. When ammonium nitrate and water mix together, so they will dissolve. So when you dissolve, okay, ammonium salt, okay, we learned just now, when you dissolve ammonium salt, it is endothermic. Okay, all right. So when you dissolve nitrate, it is endothermic. So when this is endothermic, means what? They absorb the heat from the surrounding. So when they absorb the heat from surrounding, now the surrounding here has less energy. So when surrounding have less energy, the temperature will go down. So when temperature will go down, it become cold. Okay, that's why this is a cold pack. Okay, this is a cold pack. Okay, so cold pack, we are using the concept of endothermic. Okay, when we dissolve ammonium salt, when we dissolve nitrate salt, okay, like what we learned just now, when we dissolve nitrate, when we dissolve ammonium, it is endo. So endothermic absorb the heat from the surrounding. So when you absorb the heat from surrounding, so surrounding have less energy. So when surrounding has less energy, the temperature will decrease. So it become cold. That's why we call it a cold pack. Okay. So this is what you need to know. All right. So my summary very simple. Magnesium sulfate, if you don't know, never mind. Aluminium nitrate. Okay. Aluminium nitrate. Okay. The cold pack. Okay. This one must know. Okay. That's it. So let me give you a sample question. So let me give you a sample question so you can imagine how they can ask you on this concept for your SPM. Okay, let me give you a sample question. So we put a substance X into water. Okay, we put a substance X into the water. After we put the substance X into the water, temperature go from 55 to 20. Okay, temperature go from 55 become 20. So what is the substance X? So what is substance X? So you can see here, temperature from 55 become 20. What happened? Temperature decrease. So when temperature decrease, okay, temperature decrease, this is endothermic reaction. Remember, when temperature decrease is endothermic. Okay, it's endothermic. So which substance when they dissolve in water will cause endothermic? Okay, so we learned just now. Okay, we learned just now when you dissolve nitrate or ammonium. When you dissolve nitrate, when you dissolve ammonium, so it is endo. So as you can see, what is the best answer? Donkey. Ammonium nitrate. Okay, when you dissolve ammonium, is endo. When you dissolve nitrate, also endo. So they will absorb heat from surrounding. So when they absorb the heat from surrounding, so the surrounding will have less energy. Surrounding have less energy, the temperature will decrease. That's it. Okay, you can use this concept to answer. If you don't want, you also can use another idea. So water add with a substance X, temperature go down. So when temperature go down, it become cold. Okay, when temperature go down, it become cold. So cold is cold pack. Okay? When temperature go down, it become cold. Cold pack. What is the material for cold pack? Ammonium nitrate. Okay, ammonium nitrate is the raw material to make your cold pack. Yeah. Alright, so I hope you can understand, okay, the idea, the concept, okay, how the question can be tested. Okay, so again, it's not very hard, but there are so many students making mistakes in this part. Okay, it's not very hard concept, but there are many students, they are very confused, okay, about this. So that's why I want you to understand the idea first, okay, and you will understand better when we do the tutorial number 1. Okay, when we do tutorial number 1 in the next video lesson, okay, you will understand even better. Okay, because when you do the tutorial, you can see different types of question, how they ask you, okay, how they ask you the question and how to solve those questions. Okay, all right, so that is what we need to know for now lah. Okay, all right, so after we learn the examples for endo and exothermic, after we learn about hot pack and cold pack, so the next thing we need to know is this. Okay, change of the state also involve heat. When we change the state, okay, what do we mean by state? State means solid, liquid and gas. So when we change from solid to liquid, liquid to gas, or the other way around, okay, liquid to gas or liquid to solid, okay, so it also involve the heat. Okay, it also involve the heat. All right, so okay, what you need to know is this. Okay, so look at the color of the arrow. So the red color arrow, okay, is absorb the heat. Okay, the red color arrow here, they will absorb the heat. Okay, so the blue color arrow will release the heat. Okay, so from when you change from solid to liquid, it will absorb heat. Okay, all right, it will absorb the heat. So make sense, right? Solid to liquid, what is the process? Melting. Solid to liquid, what is the process? Melting. When you want to melt a substance, what you need to do? You need to heat it, right? We need to heat the solid. So when we heat the solid, the heat go into the solid. So when solid absorb the heat, so it is endothermic. Okay, so same thing, the next one, liquid change to gas. So liquid change to gas, what is this? Is boiling, or we call evaporation. Is boiling, or we call it as evaporation. So if you have a liquid, you want to boil the liquid, what you should do? You need to heat it. When you heat the liquid, the heat go into the liquid, the heat absorbed by liquid, so it is endothermic. Okay, so that's it. All right, so the other way around, so if you go from gas to liquid, terbalik, okay, gas, you want to make it become liquid, this is condensation. This is condensation. Okay, so gas change to liquid, you need to cool down. You need to let the gas to cool down, then only you can become liquid. When you cool down something, the heat is released. When the heat is released, it is exothermic. Okay, so next one, liquid change to solid. So liquid change to solid, all right, also exothermic. Okay, right, so how to do it? When you want to change liquid to solid, this process is called freezing. When you want to do freezing process, what you want to do? You need to cool it down. You need to cool down a substance. Okay, so that when you cool down a substance, so that is exothermic. Okay, that is exothermic. All right, so that is what you need to know. Okay, all right, so here, this is a very simple idea. Okay, you how to memorize all this process. You just need to ask yourself, if that process you need to heat it, okay, then you know it's endothermic. If that process you need to cool it down, then you know it is exo. I repeat, if the process you need to heat up, then it is endothermic. If that process you need to cool down, then it is exothermic. Okay, all right, so if let's say, imagine melting is endo or exo. When you want to melt the substance, you need to heat up or cool down. When you want to melt a substance, you need to heat up, so it is endo. All right, so let's say freezing. So when you want to freeze something, when you want to freeze a liquid, you want to heat up or you want to cool down. Okay, when you want to, okay, freeze a substance, you need to cool down. So when you want to cool down, so it is, all right, exo. So this is what you need to know. Okay, just ask yourself, the process need to heat up, or the process need to cool down. That's it. Okay. All right. So this is what you need to know. Okay. All right. So now, okay, you need to understand this. Okay, all the heat absorbed or all the heat released during a chemical reaction. Okay, in a chemical reaction, all the heat that is absorbed or all the heat that is released, we call it as heat change of the reaction. Okay, we call it as heat change of reaction. Okay, example. Okay, this is a chemical reaction. This chemical reaction absorb the heat. Okay, so this heat is called heat change or of reaction. Okay, so sometimes in the books they just call it as heat of reaction. Okay, sometimes in the reference book or in textbook they can just call it as heat of reaction. Okay, all right. So same thing, if this chemical substance release the energy, when it release the energy, this energy that it release is called heat change of reaction. Okay, this is called heat change of reaction, or you can call it as heat of reaction also can. Okay, so heat of reaction is the heat that you absorb or the heat that you release during a chemical reaction. Okay, that's it. All right. Okay, all the heat that you absorb, all the heat that you release during a chemical reaction, that is called heat of reaction. Okay, so the symbol is triangle H. Okay, the symbol is a triangle H. In chemistry, triangle stand for delta. Okay, this is called delta H. Okay, delta H. So in exam, whenever you see delta H, you know that this is heat of reaction. Okay, this is heat of reaction, or you can call it as heat change of reaction also can. Yeah. All right. Okay. All right. So now let's continue a little bit. Okay. So if any equation that is come together with delta H, if you have any equation, okay, what do we mean by any equation? So we learned in your Form 5 Chapter 1, we have 3 types of equation in chemistry, right? We have chemical equation, we have ionic equation, and we have half equation. Okay, all right, we have 3 types of chemical equation, okay, in your chemistry. If any chemical equation they come together with delta H, then you can call it as thermochemical equation. Okay, so any equation that come together with delta H, so it is thermochemical equation. Okay, example. Okay, this is a chemical equation, right? Okay, this is a chemical equation. Okay, in this, if this chemical equation, you just need to add in the delta H. You can see, if this chemical equation inside got delta H, then you will call it as thermochemical equation. Okay, you will call it as thermochemical equation. Okay, same thing go for this. Say this is an ionic equation, right? This equation is ionic equation because you can see ion, you can see the charge. If this equation, you just need to add the delta H. If this equation you add the delta H, so now it become thermochemical equation. Okay, so that's it. So any equation that inside got delta H, it become thermochemical equation. Okay, like this. You might have chemical equation, you might have ionic equation, or you might have half equation. Okay, so if any of these equation they come together with the delta H, if they come together with the delta H, then all of them you will call them as thermochemical equation. Okay, so that's what you need to know. Okay, so whenever you see equation, you see an equation, and in the equation you have a delta H, then you know already that equation is called thermochemical equation. Okay, that's it. All right. All right. So the next thing, okay, why we need to learn thermochemical equation. Okay, so why we need to learn, why we need to know about thermochemical equation. Okay, so because when we refer to the sign of the delta H, when we look at the sign, okay, the sign here, okay, whether it's positive or whether it's negative, by looking at the sign of the delta H, we will know it's endothermic or it is exothermic already. Okay, so if the delta H is positive, so it is endothermic. Okay, if the delta H is negative, so it is exothermic. Okay, so that's it. All right, if the delta H is positive, so it's endo. If the delta H is negative, it's exo. Okay, so if you find it a little bit hard to memorize, okay, you can use a common sense. Okay, you can use a common sense to do it. Okay, you can use a common sense to do it. Okay, just imagine this is a particle, and this particle absorb the heat. So when the particle absorb the heat, okay, after particle A absorb the heat, particle A now has more and more energy, right or not? When imagine particle A has 40 joule, you absorb 70 joule from the surrounding. So 70 go in, add with 40 become 110 joule. Okay, so you see 40 now become 110. So the particle A has more and more energy. So if the particle A has more energy, more, how to become more? More is positive. Okay, more is positive. Okay, so that's it. So when the delta H is positive, okay, positive means more energy. So more energy means what? Absorb. Okay, they absorb. Okay, so that's how we use a common sense. Okay, so next same thing. If we have a particle B, the particle B release energy. So if the particle release, throw the energy away. So if the particle release energy, the particle now have less and less energy. Okay, less. How to get less energy? Less means negative. Okay, so simple as that. All right. So from now we can do a summary here. If the delta H is positive, positive means more. Okay, more energy. Okay, so why you get more energy? Because you absorb the heat from surrounding. Okay, when the chemical substance absorb the heat from surrounding, so it's so it is endothermic. Okay, so if the delta H is negative, negative means less, so less energy. Why the chemical substance have less energy? So it have less energy because it release the heat. Okay, so negative means release the heat. Release the heat is exo. Okay, absorb the heat is endo. Okay, so I hope by now you can know already. When you see the delta H is positive, it is endo. When you see the delta H is negative, it is exo. Okay, so sometimes you really don't need to memorize one. You really don't need to memorize. You just use common sense. You just use common sense, then you can agak-agak get the concept already. Okay, so I hope this simple common sense method can help you lah. Okay, so I repeat one more time. So if you see delta H is positive, positive means more. So why you have more energy? You have more energy because you absorb the energy from surrounding. So when you absorb the energy, it is endothermic. Okay, so when we see delta H is positive, it is endothermic. Okay, so if the delta H is negative, negative means less. So why you have less energy? Less energy because you release, throw away the energy. So when you release energy, it is exothermic. Okay, so that's it. Okay, so by looking at the sign, you should able to know the reaction is endo or exothermic already. Okay, example like this. Okay, so if you look at this equation, you look at the delta H, it's negative, so you know already. Okay, this is exothermic reaction. When you look at this equation and the delta H, when the delta H is positive, so positive means endo. Yeah, positive means endo. Okay, so by looking at the sign, you should able to know the reaction. It is endothermic or it is exothermic reaction. Okay, so it's not very hard. So same thing, we will cover many examples, okay, in tutorial number 1. In tutorial number 1, we will do more and more question together, okay, which will really improve your understanding. Okay, right? So for now, I just want you to know, okay, the delta H positive endo, delta H negative is exo, and that's it. Okay, all right. So now the next thing that you need to know is this. So in this chapter, we have two important diagrams that you need to know. Okay, we have two important diagrams that you must know in this chapter. So the first diagram is called energy level diagram. The second one is called energy profile diagram. Okay, so this part you have to be careful because there are so many students, they always mess up. They always confuse between energy level and energy profile diagram. Yeah. So let's start with energy level diagram first. So let me show you what is energy level diagram. Okay, so energy level diagram, the shape is actually staircase. Staircase is like ladder. It is like ladder. All right. So you can see something like this. Okay, so you can see ladder, right? It look like ladder. Okay, so the ladder, you have one level and one level. Okay, one level, one level, one level. Okay, so that's why they call it energy level diagram. Okay, you go from one level to another level. Okay, right? So make sure everyone know what energy level diagram, it look like staircase. Okay, it look like staircase. All right, so now, okay, look at this. So when you see a ladder like this, it is a energy level diagram. When you see a ladder like this, okay, this is, okay, energy level diagram. Okay, one level to another level. Okay, one level to another level. Okay, so that's it. So for now, I just want you to know a simple idea. When you look at these two picture, you know that they are energy level diagram. Okay, that's enough. Okay, so next one, I want to show you the difference between endothermic and exothermic reaction. Okay, what is the energy level diagram for endothermic and what is the energy level diagram for exothermic? Okay, all right, so you can see for endothermic, we absorb the heat, right? Endothermic, en, enter, the heat enter, go in. So when the heat go in, absorb the heat. So when we absorb the heat, okay, when the particle absorb the heat, particle has more energy. So when the particle has more energy, more, you will go up. Okay, when you have more, the energy will go up. So you can see the direction is going up here. Okay, so it's not very hard, right? Okay, so endothermic will absorb the heat. Absorb heat, you have more energy. So more energy, more, the staircase go up. Okay, what about exothermic? So exothermic, ex, exit. So the heat exit. So when the heat exit, heat go up. So when the heat go up, release energy. Okay, release energy. So when you release energy, after release energy, you have less energy. Okay, after we release energy, you have less energy like this. You have 100 joule. After you release 20 joule to the surrounding, so you become 80. So the energy is less. So when energy is less, so the staircase go down. Okay, so you can see the ladder here, they go down. Okay, so that is what we know. Okay, so when you look at the ladder go up or go down, you should know is endo or exo already. Okay, when you see go up means what? The energy go up, you have more energy. Okay, more energy. Why you have more energy? Because you absorb the energy from surrounding. So when you absorb energy from surrounding, it is endothermic. So that's it. So when you see the energy go down, so energy go down means what? Less energy. Okay, when you see the energy go down means less energy. Why the energy is less? Because we release the heat. Okay, when we release the heat, when we throw away the energy, so is the energy become lesser. So release heat, it is exothermic. Okay, all right, so now you should know already. Okay, now you should know how to know the reaction is endo or exo. You have two way to know. Number one is look at the delta H. Look at the delta H. Okay, when you look at the delta H, positive is endo, negative is exo. Okay, another way to know the reaction is endo or exo is look at the staircase. If the staircase is going up, so it's endo. If the staircase is going down, it's exo. Okay, right. So this is how the question can ask about endo or exo. Okay, we can look at the energy level diagram. We also can look at the delta H. Two things here. All right. So now the next thing, I'll teach you step by step how to draw the energy level diagram. Okay, I'll teach you step by step how to draw the energy level diagram. Okay, so you don't memorize. You don't need to memorize. I'll teach you, okay, step by step, okay, on how to draw the energy level diagram. Okay, so if you want to draw energy level diagram, first of all, you need to label a y-axis. Okay, so you need to label the y-axis. So the y-axis is energy. Okay, so you see here, this is the y-axis. So the y-axis is the energy. That's why we call it energy level diagram. Okay, it's called energy level diagram because we want to study about energy. Okay, so x-axis, no need to label. So you don't need to draw the x-axis at all. I repeat, in energy level diagram, you don't need to draw the x-axis at all. No need. Just keep it empty. Yeah? So this is the x-axis. No need. You don't need part cx. You don't need part cx. You only want part cy. Okay? We only want the y-axis. We don't want the x-axis. Okay? So this is the first concept. Number two. Now you want to draw one horizontal line because energy level diagram. So level you must have staircase. So how to draw the staircase? Okay, this is your y-axis, this is energy. So you need to draw a horizontal line first. Okay, so you can draw the horizontal line at here, or even at here, no problem. Normally I draw in the middle. Normally I draw somewhere here in the middle. Okay, so draw one horizontal line. So this horizontal line, you need to put reactants on the line. Okay, you need to put reactants on this line. So what is reactant? Reactant means raw material. Okay, the raw material is reactant. Okay, so now you already draw this one. Okay, so after you draw this, okay, so what is the next thing you should do? Okay, so the next thing that you should do is this. Okay, so let's look at it. So the next thing, you need to look at the delta H. You need to look at the delta H, the sign of the delta H. If the delta H, the sign is positive, the staircase will go up. If the delta H, what we call that, it's negative, the staircase will go down. Okay, this is quite simple, right? Y-axis going up is more positive, going down is more negative. Am I right? Simple mathematical concept. Okay, y-axis go up is positive, go down is negative. Okay, so if the delta H is positive, so the ladder will go up. Okay, if the delta H, okay, let's say this is reactant. If let's say the delta H is positive, so you go up. Okay, if the delta H is negative, you go down. That's it. Okay, all right. So let me show you two examples. Okay, you see, okay, all right. So this is the reactant. So if the delta H is, okay, negative, so if the delta H is negative, so negative, you will go down. If the delta H is positive, okay, if the delta H positive, you go up. Okay, so that's it. All right. So lastly, after you go down or you go up, so now you draw one more horizontal line. Okay, you draw one more horizontal line and you put product on the line. Okay, so what do I mean? You see, so after you go down, you draw one more line here, and this line you put products. Okay, so you see, now you get the ladder already. Okay, so what about here? Okay, what about this one? Same thing. So after you go up, so you draw another one horizontal line. Okay, you draw another one horizontal line, and this one you put products. Okay, so that's it. Okay, so you can see now you can get a ladder. All right, so it's not very hard, right? Okay, it's not very hard. Okay, so after you draw one more line, you put product. So like this. Okay, so this is reactant. So go down. So this is product. Okay, reactant. go down, product. Okay, or you can get this reactant, go up, products. Okay, so that's it. All right, so after you do all the thing, then in the end you need to put the delta H beside the arrow. Okay, you need to put delta H beside the arrow. So this arrow here, you need to put delta H. Okay, so this arrow here, beside here, you need to put a delta H. And the delta H, you need to put the sign, must put the sign. Okay, like this. Okay, if the delta H go, if this one go down, so go down, it's negative, right? Okay, so if this one go up, delta H is positive. Okay, so that's it. Okay, step by step. All right. Okay, so now I will show you example. Okay, so you can imagine better. So I will do one example with you. Then you need to do one self-test for me. Okay, I will do one example with you. Then you need to do one self-test for me. Okay, so let's do it. So you see, now you are given a chemical equation, and this chemical equation come together with delta H. So this is a thermochemical equation. So this is a thermochemical equation. So now the question want us to draw. So now the question want us to draw the energy level diagram. So energy level diagram, what it is? Staircase. So we need to draw the staircase. So how to draw? Okay, first of all, draw your y-axis. Okay, draw the y-axis first. Okay, draw the y-axis. So the y-axis you must label as energy. Okay, you must label as energy. That's why we have energy level diagram. Okay, so next one. So now we need to start to draw the staircase. To start to draw the staircase, we need to draw one line, one horizontal line. So this horizontal line, you can draw on top, you can draw at the bottom, also can, but I draw normally in the middle. Okay, I draw in the middle. Then on this line, you need to put reactant. What is reactant? Reactant is the raw material. Okay, how to know what is the reactant? Okay, what is the reactant? So when you have a chemical equation, everything on the left hand side here, they are reactant. They are the raw material. Everything on the right hand side here, they are product. Okay, so this is a simple concept you learn in Form 4, Chapter 3. Okay, everything on the left hand side of equation is reactant. Everything on the right hand side of the equation, they are products. Okay, so that's what we need to know. Okay, so now we need to put the reactants on the arrow here. Okay, so let's do it. So we copy these two things into here. So we put Mg plus CuSO4. Okay, so now we are done with this. Okay, so the next thing, now you must know the now you must know the staircase want to go up or the staircase want to go down. Yeah, you must know the staircase will go up or the staircase will go down. So how to know the staircase will go up or go down? Look at the delta H, the sign. So when the sign is negative, so negative will go up or go down. According to number line, go down is negative, go up is positive. Okay, so you want to go down. Okay, you want to go down. So you must draw a line going down. Sorry, you must draw a line going down, and you must draw the direction. Okay, you must draw the direction. Okay, so now the next thing, you need to draw one more line so that you have the staircase. Okay, so draw one more line. So this line is your product. Okay, this line is your product. Okay, so what is our product? So product is everything on the right hand side of the equation. Everything on the right hand side of the equation is the product, which is these two. Okay, so we copied it. Okay, we copied it. MgSO4 and Cu. Okay, so now we already draw everything. So there's one more thing, don't forget. Okay, look at the step 5. In the end, you must put the delta H beside the arrow and put the sign. Okay, so now where is the arrow? Here. So you must put in your delta H. So what is the delta H? Okay, copy the whole thing. Negative 467 kilojoule per mole. So negative 467 kilojoule per mole. Okay, that's it. So now you already get the good energy level diagram. Okay, so everyone must know how to draw energy level diagram. This is a very, very popular question in your SPM. This is a very, very popular question for your SPM. Okay, so we are done with this. So the next thing, okay, so the next part will be a self-test. So self-test, now is your turn to do. Okay, now I want you to try to do. Okay, so you are given an ionic equation. This is an ionic equation come together with delta H. So when the equation come together with delta H, this is a thermochemical equation. So now I want you to use this thermochemical equation to draw the energy level diagram. Okay, try to draw the energy level diagram for this question. Okay, so you can pause the video. Okay, you can stop the video and try to do this question on your own first. Okay, then only I will check, I will go through the answer, okay, with you one by one, step by step. Okay, so you can try to do it now. Okay, so press the stop button and then try to do this question on your own first, okay, before we discuss about the answer. Okay, so let me show you how to solve the question step by step. So we want to draw energy level diagram. So first of all, we draw the y-axis. So the y-axis must be labeled as energy. So we don't need to draw x-axis, no need. So we need to start with one horizontal line. Okay, so this horizontal line need to put the reactant. Reactant is the raw material. What is the raw material here? The left hand side. Okay, so Ca2 plus and 2Cl minus. Okay, Ca2 plus, sorry. Okay, I should put somewhere here. Okay, all right, Ca2 plus and, okay, 2Cl minus. Okay, so now we need to know the staircase will go up or go down. So the delta H is positive. Positive means go up. So positive is go up. So the staircase will go up. So make sure you go up and you put the arrow, the direction. So then we need to draw another one more line here to complete the staircase. So now this line is the product. So what is the final product? The final product is here on the right hand side, CaCl2. Okay, so now we are done. And don't forget, we need to label the delta H here. Okay, we need to put a delta H beside the arrow. So what is the delta H? This one, positive 150 kilojoule per mole. That's it. Okay, so this is the value that we need to get. Yeah, all right, so that's it. Okay, so if you're able to draw this energy level diagram, okay, you should able to score about 2 marks if they ask this question in subjective. So in SPM, this is a very, very popular question. This is a very popular question. They love to ask you to draw the energy level diagram, okay, especially in subjective. Okay, they love to ask this in the subjective question. So make sure everyone know how to draw the energy level diagram. Okay, so now after we learn about energy level diagram, the next thing that we need to know is this. So when we are given energy level diagram, okay, so what if now we already have energy level diagram? So there are 3 informations that can be obtained. So we can always get 3 information, okay, from the energy level diagram. Okay, so if you are given this energy level diagram, you're always able to get 3 important information. Okay, 3 important information. Okay, so what are the 3 informations that we can get? Okay, what are the 3 information that we can get? Okay, the first thing, from the energy level diagram, we should able to tell, we should able to know the reaction is endothermic or exothermic. Okay, we should able to know the reaction is endothermic or exothermic. Number 2, we should able to know how much the heat is being absorbed or how much the heat is released. Okay, how much the heat that absorbed or how much the heat is released. And then after that, we should able to know total energy of reactant and total energy of product. Okay, so we should able to know the reactant has more energy or the product has more energy. Okay, so I know you might find it very blur here, which is normal. So the best way for us to learn is by using example. Yeah, the best way to learn is by using example. So I'll show you example how to get three information, okay, from the energy level diagram. Okay, so let me show you this. So you see, so we are given thermochemical equation. Okay, let's say now we have thermochemical equation and we have energy level diagram. Okay, so from this energy level diagram, I want to get three information. Okay, so the first information I can get is whether the reaction is endo or exo. Okay, I can know from this energy level diagram whether the chemical reaction is endo or exo. How I know? I look at the sign. By looking at the sign of the delta H, I will know is endo or exo. So when you see negative, negative means exo. When the delta H is negative, it is exo. So from here, I know already this is an exothermic reaction. Okay, so I know already this is exothermic reaction. Okay, so the next one. Okay, so I can find out how many heat which is absorbed or how many heat is released. Okay, right, so how to know how many heat is absorbed or released? Okay, first of all, you look at it. So now we have magnesium. How many magnesium we have? 1 mole. Okay, when we have 1 mole of magnesium react with how many copper sulfate? 1 mole. So you see, when 1 mole of magnesium reacts with 1 mole of copper sulfate. Okay, so what is the final product? So we produce magnesium sulfate. How many? 1 mole. We produce copper. How many? 1 mole. So you see, so to produce 1 mole of magnesium sulfate and 1 mole of copper. Okay, so now we need to tell when 1 mole of magnesium react with 1 mole of copper sulfate to produce 1 mole of magnesium sulfate and 1 mole of copper. Okay, so now how many heat is absorbed or released? So the heat that is absorbed is here, so it's 467. Okay, what is the unit? Kilojoule. Okay, energy we use kilojoule. So the mole here, no need to write. You don't need to write the mole here. Why? You already mentioned the mole at here. So all the mole you already mentioned in front. So now you don't need to write the mole already. Okay, and when you see the delta H is negative, negative is what? Exo. So exothermic is what? Exothermic is release. Exothermic will release the heat. So you see, 467 kilojoule of heat. Okay, 467 kilojoule of heat is released. Okay, so why we know the heat is released? Okay, all right, because when we see negative, negative means exo. So exo will release the energy. Okay, release how many? Release 467 kilojoule. Okay, release 467 kilojoule. So when you write release energy, so the sign here you don't need to put in already because the sign already tell us is release energy. Okay, the sign here already tell us is release energy, so you don't need to write minus 467 kilojoule of heat is released. No need. Yeah, so this part is a little bit more technical. This part is a little bit more technical that you have to be very, very careful. Okay, and always remember, no matter the heat is absorbed or released, no matter we absorb or release the heat, you must refer to surrounding. Okay, when you absorb the heat, you absorb the heat from the surrounding. When you release the heat, you release the heat to the surrounding. Okay, so this part you have to be very careful. Okay, so we have 400, okay, 67 kilojoule of the heat is released to surrounding. Okay, all right, so next one, Okay, now the third thing we can compare is the total energy. So now we can see who has more energy. Okay, who has more energy? So how to know who has more energy? You just need to look at which part is higher. You can see the reactant is higher, right? The reactant is higher than the product. So when the reactant is higher than the product means what? The reactant has more energy. So you can write the total energy content, okay, the total energy content, okay, of reactant is higher than the total energy content of product. You can see, right? The reactant is here, okay, the reactant is here, and then your product is here. So the reactant has higher energy than the product. Okay, so learn this word, total energy content. Total energy content of reactant is higher than total energy of product. Okay, that's it. So you can also explain in the other way around. You can also explain terbalik in the other way around. Just now, I just mentioned reactant is higher than product. You can go the other way around. You can talk about product first also can. You can say product is lower than reactant also can. You can say the product, the energy is lower than the reactant. So you can also write this, or you can write total energy of product is lower than the total energy content of reactant. Okay, so that's it. So you just need to compare and you just need to mention who has more energy, whether the reactant has more energy or the product has more energy. Okay, so no problem. Okay, you can put the product in front. You can say product is higher than reactant, or you can say reactant is higher or lower than product. No problem one. Okay, up to you. Okay, so when you compare the total energy, you want to put the reactant in front. Okay, is higher or lower than the product, or you can terbalik. Okay, you can put product in front and the reactant at the back also can. Yeah, up to you. So these are the three information that you can get from energy level diagram. Okay, so I repeat one more time. So from this energy level diagram, what you can see, so it is exothermic because the delta H is negative. So you can see 1 mole of magnesium react with 1 mole of copper sulfate will produce 1 mole of magnesium sulfate and 1 mole of copper. Okay, and this chemical reaction minus means release. It will release how many? 467 kilojoule. Okay, what you release? Release heat. Okay, you release the heat. Where you release the heat? To the surrounding. You release the heat to the surrounding. Okay, so that's it. So after that, you can mention who has higher energy. So like this, you can say total energy content of reactant is higher than the total energy content of product. Okay, so three important information, yeah, that you can get from the energy level diagram. Okay, so now same thing, I would like you to try to do the self-test. So let's try to do the self-test question. Okay, so the self-test question, now you are given the energy level diagram. You are given energy level diagram. So I want you to give me the three information. Okay, so write down the three information that you can get from this energy level diagram. Okay, so write down the three information that you can get from the energy level diagram. Okay, so you can refer to this. Okay, you can refer to my previous example. Okay, and then you can try to do this on your own. Okay, you can try to do this on your own. Right, so press the stop button. Okay, and then you try to do it, and then we discuss about the answer. Okay, so what are the three important informations that we can get from here? So the first thing, as you can see, the delta H is positive, so it is endothermic reaction. So this is endothermic reaction. Number two, we need to mention what is this reaction all about. So we have 1 mole of Ca2 plus. So Ca2 plus have charge, you must put the word ion. So 1 mole of Ca2 plus ion react with 2 mole of Cl minus ions. Okay, so you see, you have 1 mole of Ca2 plus ion react with 2 mole of Cl minus ion. So after react, what happened? They will produce how many? 1 mole of CaCl2. Okay, so they will produce 1 mole of CaCl2. So you need to mention what is this chemical reaction all about first. So after you mention what is the chemical reaction, then you must mention whether this chemical reaction absorb or release the heat. Okay, you need to mention this chemical reaction absorb or release the heat. So you can see positive. Positive is endo. Endo means absorb. Okay, so you will absorb. Absorb what? Absorb the heat. How many heat you absorb? 150 kilojoule. You absorb 150 kilojoule. So remember, when you mention how many heat you absorb, how many heat you release, this mole you don't need to put in. Okay, you just need to mention how many kilojoule of the heat is absorbed or how many kilojoule of the heat is released. Okay, so you can write 150 kilojoule of heat is absorbed. And you need to mention where the heat is coming from. Always mention surrounding. Okay, so you always absorb the heat from the surrounding and you will release the heat to the surrounding. Okay, so make sure you know how to write it. Okay, make sure you know how to write this. Okay, so that's it. Okay, so now this is the second information. All right, so the next one, the third one, now you can compare the total energy. Okay, you can compare the total energy. Okay, so you can say the total energy content of reactant. Okay, so you see the reactant, the energy is lower than product. Okay, so you can write total energy content of reactant is lower than the total energy content of product. So if you don't want to do this, you can go the other way around. Okay, if you don't want to do this, you can go the other way around. You can write product first. Total energy of product. So you see, this is product. Total energy of product is higher than the total energy of reactant. Okay, so total energy content of product is higher than the total energy content of reactant. Okay, so that's it. So you just need to write one of it. You can write this one or you can write this one. You don't need to write both. You don't need to write both. You just write one of them. Okay, so that's it. Okay, so these are the three important information that you can get from this energy level diagram. Okay, so you can tell endo or exo. Then you need to mention how many mole of reactant react to produce how many mole of product, and during the chemical reaction, how many kilojoule of heat is absorbed from the surrounding, or how many kilojoule of heat is released to the surrounding. Okay, then you must mention total energy of reactant is higher or lower than the total energy content of the product. Or you can go the other way around. Total energy content of product is higher or lower than the total energy content of the reactant. So that's it. Okay, you just need to compare the total energy. Okay, so you can see the energy level diagram is very, very informative. From the energy level diagram, we can get so many information. Okay, we can get so many information from the energy level diagram. Okay, so I hope these two examples can give you a better idea, okay, what you can get from the energy level diagram. Okay, so now we will move on to the last part. Okay, so the last part for today's lesson that we need to know is energy profile diagram. Okay, so we already learned about energy level diagram. So now let's move on to the next one, which is energy profile diagram. So what is energy profile diagram? So energy profile diagram is actually the diagram. Okay, the shape is actually a staircase plus a peak. okay, is a staircase plus a peak. Okay, all right. So what do I mean? Okay, let me show you these two diagram here. Okay, you can see energy level diagram, you go one level and one level, level by level, so it is a staircase. Okay, so that's why you can see energy level diagram look like a staircase. Energy level diagram look like staircase. Okay, so energy profile diagram, profile P, profile P stand for peak, P stand for peak. Okay, so you will see a staircase and a peak. So you can see now you still can see staircase, right? Ladder, right? You still can see the ladder, the staircase, but now you see a small mountain. You see a small mountain. This small mountain is a peak. Okay, so that's it. Okay, so make sure when you get the picture, right, when the picture only show you something like this, so this is energy level diagram. But if the picture you can see something like this, okay, you can see a small mountain, this is energy profile diagram. Okay, so you must able to differentiate, you must able to see the difference between energy level diagram and also energy profile diagram. Okay, you need to differentiate, because many students, they always mess up these two, they always confuse between these two. Okay, all right. So now this is the strategy. Okay, so I don't want you to memorize the energy profile diagram. So you don't need to memorize the energy profile diagram. So what you need to do is that you can modify the energy level diagram. Okay, so I'll teach you how to change the energy level diagram. You can do some modification, so you can change the energy level diagram to become energy profile diagram. Okay, just modify. Okay, you just need to modify, you don't need to memorize. Okay, all right, so I'll show you step by step how to do it. So these are 3 steps. Okay, these are the 3 steps that we can use, okay, to change the energy level diagram to become energy profile diagram. Okay, so I'll use example to demonstrate. Okay, I'll use 2 example here to demonstrate. Okay, I'll show you 2 example here. Okay, so first of all, this is energy level diagram, right? You can see staircase. This is energy level diagram. So I'll teach you how to modify. Okay, so step number 1, you need to remove the arrow. Okay, remove the arrow from the staircase. So this is the staircase, I want to remove the arrow. Okay, so you need to remove this one, remove this arrow, and also remove the delta H. Okay, remove these 2. I repeat, remove the arrow and remove the delta H. Okay, so let's do it. So this arrow, remove. Okay, this delta H, remove. Okay, remove first. Okay, so after we remove, so now we push the back part to the right. So push the back part to the right. Okay, what do we mean by back part? Okay, so this is the front and this is the back. So we want to push this. Okay, we want to push this back part to the right hand side. Okay, so you can see now this one, you just need to push a little bit to the right, just a bit only. You don't need to push so far like this, no need. Just push like you see here, a bit to here. Okay, push a bit to here. All right, so after you push a bit, so the next thing what you can do is that now you can draw a curve. You can draw a curve. Okay, the curve is the N curve. You draw a N curve connecting 2 horizontal line. You draw a N curve, connect 2 horizontal line. So you can see, so you take this end point and here the starting point. Okay, you see, end point here and the starting point here, you draw a curve like this. Okay, just draw a curve will do. The curve must be N curve. You cannot draw a curve like this, U curve. I don't want a U curve. Okay, we must draw a N curve. Okay, all right. So just draw N curve will do. Okay, so that's it. So this N curve, you must make sure the highest point must be higher than this line and this line. Okay, you must make sure the highest point must be higher than this line and this line. So that's it. Okay, so this is how you draw it. Okay, you cannot draw like this. You cannot draw. Okay, this one cannot. Okay, you must make sure that when you draw a curve N shape like this, so this point must be higher than this. This point must be higher than this. Okay. Alright, so now you already modified your energy level diagram to energy profile diagram. Okay, you see energy profile diagram, you have staircase and you have the peak. So you can see now I still have the staircase, the ladder, and I have a peak, I have a mountain. So this is how we modify. This is how we modify. Okay, alright. So we try one more example. Okay, we try one more example. Okay, so same thing. This is another energy level diagram. Okay, you can try on your own first if you want. Okay, then I'll show you how to do the modification. So to do the modification, so first of all, we need to remove the arrow from the staircase. So this staircase, we remove the arrow and we remove this delta H. Just remove. So after we remove, so now we push the back part to the right. So this is the back part. So we push it to the right hand side here. Just push a bit to here. Okay, right hand side. So after push to the right hand side, so then we draw a N curve connecting the lines. Okay, we draw the N curve. So the N curve you must draw at here and here. So draw the N curve. So the N curve like this. Okay, just draw the N curve like this. Okay, so that's it. Alright, so make sure the N curve, this point must be higher than this, must be higher than this. So the mountain must be higher than these two lines. The mountain must be higher than these two lines. Okay, that's it. Alright, so now you already get your energy profile diagram. Okay, so I hope everyone understand how I modify energy level diagram to become energy profile diagram. Because many students, they try to memorize. They try to memorize the whole thing. Okay, so so now you don't need to memorize. You just need to modify. You can just modify. Okay, as simple as that. Okay, right. So now we are done with the modification of energy profile diagram. Okay, so we have learned how to convert energy level diagram to become energy profile diagram. Okay, so the next thing, okay, all right, so the next thing that we need to know is this. All chemical reaction always involve two steps. Okay, in chemistry, all the chemical reaction, they always involve two steps. So step number one, the reactant, they need to absorb energy to break the bond. Okay, all the reactant, they need to absorb the energy to break the bond. So break the bond means, okay, like this. Okay, this is the reactant, the raw material like this. Hydrogen plus chlorine, you want to form 2HCl, for example. So these two are the reactant. Reactant means raw material. So the raw material, they need to absorb the energy to break the bond. You can see H2 means what? H2 means H and H, they bond together. Cl2 means Cl and Cl, they bond together. So they need to absorb the heat. Okay, they need to use the heat coming in to break the bond. They need to use the heat coming in here to break the bond. Okay, so the reactant, raw materials always need to absorb energy to break the bond. Okay, so now after the bond are broken, okay, after you break the bond here, so what happened? Product, they will release energy to form the bond. Okay, so the product will release energy to form the bond. So you can see now, if the H and Cl want to combine together, okay, so if now the H and the Cl, they want to combine together, they need to form the bond. So when they form the bond, they will release energy. Okay, they will release the heat. Okay, so same thing. So the H and the Cl, they want to bond together. So they want to form a bond. So when they form a bond, they will release the energy. Okay, so this concept is very important. If you want to break the bond, you need to absorb energy. If you want to form the bond, you need to release energy. Okay, So this is not very hard, okay? And you must know who need to break bond. So the one that need to break bond is the reactant, the raw material. Who need to form bond? You want to form product. Product will form the bond. Okay, so this concept is very important. Okay, reactant, the raw material, they are reactants. They will break the bond. So how they break the bond? They need to absorb energy. So to produce the product, they need to form new bonds. When they want to form the bond, they will release energy. Yeah, so that's what you need to know. Okay, so in exam, sometimes they will give you bond energy. Okay, they will give you bond energy. So the bond energy you can use to calculate the heat change of reaction. Okay, so sometimes they will ask you to calculate the heat change of the reaction. Okay, they ask you to calculate the delta H by using bond energy. Okay, so in SPM, okay, in SPM, if they ask you to do calculation of delta H, okay, if in SPM they ask you to do calculation of delta H by using bond energy, okay, if in SPM they ask you to calculate the delta H by using bond energy, then you need to use this formula. Okay, this is the formula for you to calculate the delta H by using bond energy. Okay, so to do that, so this formula is what? Energy to break the bond minus energy to form the bond. Okay, in chemical reaction, you always need to break the bond, then only form the bond. And the sequence is important. You must break the bond first, then only you form the bond. That's what you see. That's what you can see. Step 1 is break bond. Step 2 is form bond. Okay, so that's why you must put break bond minus form bond. Cannot terbalik. You cannot terbalik. You cannot write form bond minus break bond. Cannot. Always break, then only form. Always break, then only form. Okay, so how they can ask you the question? Okay, so same thing, I'll give you an example and you will do a self-test for me. Okay, I'll give you an example and you will do a self-test for me. Okay, all right, so let's do it together. So let's do this question together. Okay, all right, so you can see this question, they give you a table. So in this table they will tell you there are 3 types of bond. Okay, you have 1, 2, 3, 3 types of bonds, and also the bond energy. Okay, so they will tell you what are the bonds and also the bond energy. So the question is asking okay, the question is asking us to use the bond energy to calculate heat of reaction. Okay, they ask you to use the bond energy to calculate heat of reaction. Okay, so how to do that? Okay, so if you are given the question, okay, if they give you the bond energy, so I want you to split into 2 parts. Okay, so this is the left hand side, this is the right hand side. So I want you to split into 2 parts. Okay, always split into 2 parts. Okay, so the left hand side is the reactant. Left hand side is the reactant, the raw material. So raw material, what we need to do? We need to break the bond. So left hand side, let's write here. So left hand side, we need to break the bond. Okay, so what are the bond that you need to break? Okay, what are the bond you need to break? Okay, so H2. So H2 is what? H2 means H and H. H2 means this. Okay, H and H bond together. So you copy this HH. Okay, so we copy HH bond here. Okay, what else you need to break? Cl2. Cl2 means what? Cl and Cl. So this whole thing, you just need to copy. You just need to copy here. Cl and Cl. So now you ask yourself, how much energy that is needed to break the H and H? So you see a given H and H, 436. So it's 436. Okay. Cl and Cl, how much energy you need to break? So look at the bond energy here. Cl and Cl, it is 243. So 243. Okay, so you need 436 to break the H2. You need 243 to break the Cl2. Okay, so these two energy, you just need to add together. So you just add together, so it becomes 679. Okay, 679. Okay, so that's the first part. So now, next one, go to the right hand side. So right hand side, this is the product, right? Right hand side, we have product. So product, what we need to do? Product, we need to form the bond. Product, we need to form the bond. Okay, so here we need to form the bond. Okay, so what are the bond that we need to form? We need to form HCl. Okay, we need to form HCl, right? How to draw the HCl bond? Look at the picture here, HCl. So HCl bond. How many HCl bond we need to form? You look at it, you have two HCl, right? We have two HCl. So the HCl bond, we need to form two of it. So we need to times 2. Okay, we need to form 2 HCl bond. Okay, so how to do the calculation? HCl bond, what is the energy? 432, right? So this is 432. Okay, and then you must multiply by 2. Okay, because one of the HCl, the bond energy is 432. We have 2 HCl. You can see we have 2 HCl here. So you must multiply by 2. So when you multiply by 2, what is the value you are getting? You are getting 864. Okay, alright, so that is the energy for forming bond. Okay, so now you already get breaking bond and forming bond. So now you want to find delta H. Okay, so if you want to find delta H, you need to use this formula. Okay, so the delta H is equal to energy to break the bond minus the energy to form the bond. Okay, so that's what you do. All right, so just put in how much energy to break the bond here, 679, minus how many energy to form the bond. Okay, so to form the bond, we get the value from here, 864. Okay, all right, so now we get all the numbers already. Okay, so now we already get all the numbers. Okay, so now you just need to put in this, key in this into your calculator. So when you key into the calculator, you will get minus 184. Okay, so 185, sorry. So when you do the calculation, when you are doing calculation, don't forget to put in the unit. So what is the final unit? So copy back, copy back the unit here, kj per mole. This unit just copy back. Okay, kj per mole. Okay, so now you are done with this calculation. Okay, so it's not very hard, you just need to do it step by step. Okay, so now for the next question, this is a self-test. Okay, this is a self-test that you should try to do it as an exercise. You can try to practice on it. So now in this question, I will give you two bonds and I'll give you their bond energy as well. Okay, I'll give you two bonds and I'll give you their bond energy as well. So the question is asking you to use the bond energy to calculate the heat of reaction. Okay, use the bond energy to calculate the heat of reaction, the delta H. And this is your chemical equation. Okay, so now pause the video. Okay, so pause the video and try to do this question on your own first. Okay, just pause the video and try to do on your own. Yeah. Okay, so how to do the question here? Okay, so same thing when you want to use the bond energy. So when you want to use the bond energy to do calculation, you need to split into two parts. Okay, you need to split into two parts. So the left hand side, you need to break the bond because they are reactant. And the right hand side, you need to form the bond because they are product. Okay, so now you need to list down what are the bond you need to break and what are the bond you need to form. So here you have carbon. So carbon, do you have any bond on carbon? No, right? You only have C. You only have one carbon who come alone. So the carbon do not bond with anything else. The carbon do not bond with anything else. So no need to break the carbon here. So O2. O2 means what? You have two oxygen bond together. What is the bond of oxygen? Here, right? O and O. O2. So you can see the O2 here have double bond. So just copy lah. Just copy here. O and O. Okay, double bond. Okay, O and O. Double bond. Okay, that's it. So how much energy we need to break the O2? So it is 495. Okay, so we just need to put 495 here. Okay, all right. So do we still have other bond to break? No, right? Okay, no more. Right, so the total energy to break bond is 495. So the total energy to break the bond is 495. Okay, what about form bond? So what are the bond we need to form? We need to form what? This is CO2. So CO2, okay, what is CO2 here? CO2, we have one C bonded with two O. So the C here bonded with O and bonded with O. The C bonded with O and bonded with O. So as you can see, the C and O is double bond. So C and O is double bond. C and O is double bond. So you need to draw C double bond O. So how many C double bond O we have? So you can see here, C double bond O. That's one of it. Then C double bond O, another one. So we have two C double bond O. So this C double bond O, we have two of it. So you must times 2. Okay? So what is the value here? C double bond O, it is 740. Yeah? So it is 740. So 740 is for one C double bond O, but we have two C double bond O, because you can see CO2, one of the C bonded with here, O, another C is bonded with here. So here we have one CO bond, here we have one CO bond. That's it. Okay? All right. So now it's 740. Okay, so we just need, so the total here is 740. Okay, so now how to find the delta H? So as what we see just now, to find the delta H using the bond energy, we need to use the formula. Okay, we need to use the formula. Energy to break bond minus energy to form the bond. Energy to break bond, okay, minus energy to form the bond. So how much energy to break the bond? 495. Okay, minus form bond, it's 740. Okay, 740. So when we minus it, so what is the value? So now we just need to key into the calculator. Yeah, we just key into calculator. We will get negative 245. Okay, so when you do calculation, don't forget about the unit. Please don't forget about the unit. So what is the unit? Refer back kilojoule per mole. Just copy. Okay, just copy kilojoule per mole. Okay, so now we are all done with this calculation. Okay, so it's not very hard. Just follow the step. Just follow the step. Okay, so if you want to calculate the delta H by using the bond energy, you need to take the energy to break the bond minus the energy to form the bond. Yeah, so that's it. All right, so now we will go on with another one more part. Okay, so just now we already learned the energy profile diagram. So we already learned how to modify the energy level diagram to energy profile diagram. So now the next thing, after we modify, so now we need to know how to analyze. So if you are given the energy profile diagram, so what you need to know, okay, what you need to know about the energy profile diagram. Okay, so here there are three important things you must know. Okay, so the gap between the reactant to the peak means the highest point, is actually the total energy absorbed to break the bond. Okay, so the gap between reactant to the peak, okay, is the total energy to break the bond. So the total energy to break the bond, also known as activation energy. Okay, this one also known as activation energy. This is something we learned in Form 4, Chapter 7. We learned this in your Form 4, Chapter 7. Okay, so let's look at it. Alright, so you see this is an energy profile diagram. So the gap between reactant and the peak, okay, this gap is activation energy. Okay, this gap here is actually activation energy. Activation energy, the symbol is EA. E stand for energy, A stand for activation. Okay, so this is activation energy. Okay, right, so from here to here, okay, this is the energy that we need to break the bond. Okay, from here to here, this is the energy that we need to break the bond. Okay, all right, so next one, the gap between the peak to the product. Okay, the gap between the peak to the product is the total energy, okay, released to form the bond. Okay, so you see this is the peak and this is the product. So this gap here, okay, so this gap here is actually the total energy released to form the product. So you see, quite simple. From reactant to the point here, this is the energy you absorb to break the bond. From here to here, okay, from the highest point to the product, this is the energy to break the bond. Okay, this is the energy to break the bond. Okay, sorry, to form the bond. Sorry, so here to here, this one is the total energy to break the bond. So here to here, this is the energy released to form the bond. Okay, so reactant and product. Okay, so you see, reactant to the highest point, this is the energy you absorb. So from the highest point to the product, this is the energy that you release. Okay, so that is what we need to know. Okay, and the gap between this peak and also the reactant, this absorbed energy, also known as activation energy. Okay, also known as activation energy. Okay, all right. So now the third one, the gap between the staircase, the gap between the staircase is heat of reaction, delta H. Okay, the gap between the staircase is heat of reaction. So this is staircase and this is staircase. So the gap between these two, okay, this is your delta H. Okay, that is what we need to know. Okay, this is the delta H. Alright, so these are two very important label you need to know. Okay, EA and also delta H. Okay, alright, so show you another one more example. Okay, let's do another one more example here. Okay, now, okay, so this is energy profile diagram. Okay, so let's label. So the first thing, the gap between the reactant to the peak, okay, is the total energy absorbed to break the bond. Okay, and we can call it as activation energy. Okay, so you see, from the reactant to the peak here, okay, so this gap is activation energy. So activation energy is what? The total energy that is absorbed to break the bond. Okay, the total energy absorbed to break the bond. So this is activation energy. Okay, so here, so from here to here, this is the total energy that we absorb. Okay, all right, so what about this? From the peak to the product here, from the peak to the product, this one, this is the total energy released to form the bond. Okay, all right, so I repeat, okay, so from here to the highest point, absorb energy. Okay, this is the energy you absorb okay, to break the bond. So from here to the product, go down. This is the energy you release to form the bond. Okay, so same thing like just now, right? This one from the bottom to the top here, okay, from the reactant to the peak, okay, this is the energy you absorb to break the bond. From the peak to the product, this is the energy you release to form the bond. Okay, that's it. All right. And the most important label you need to know is where is the activation energy. Okay, the activation energy is the gap between the peak to the reactant. Okay, so the gap between the staircase is the delta H. Okay, the gap between the staircase is your delta H. So look at the staircase here. Okay, so this question, let us look at the staircase. All right. Okay, so this is the staircase and this is the staircase. So staircase and staircase, so the gap here is your delta H. Okay, so this is staircase, this is staircase. So the gap here is your delta H. Okay, so make sure you know this. Okay, so these are the two most important label, the EA and the delta H. Okay, that's it. So if the break bond and form bond, this one is too confusing for you, you don't need to know. It's okay. As long as you know where is the EA and where is the delta H, then it's good enough already. Okay, as long as you know where is the activation energy and where is the heat of reaction, that is good enough already. So I repeat one more time. So how to get the activation energy? Activation energy is from the peak to the reactant. So here is activation energy. So where is the delta H? Delta H is the gap between the staircase, the gap between the staircase. Staircase and staircase, the gap here is delta H. Okay, so these are the two important things. Okay, the delta H and the activation energy. So if you don't know this breaking bond, you don't know this forming bond, it's okay. It's okay. Yeah. Right. Let's try another one more example. Okay. What about this? So same thing. Okay. Can you try to label where is the activation energy? So can you try to label for me where is the activation energy? So activation energy is always from the peak to the reactant. The peak to the reactant here. So this is activation energy. So next one. Can you label for me where is the delta H? Where is the delta H? So the delta H is always the gap between the staircase. So this is staircase, this is staircase. So the gap between the staircase here is your delta H. Okay, that's it. Okay, you know how to label these two, that is good enough already. Okay, you know how to label these two, that is good enough already. Okay, so same thing, we will do more exercise on this in tutorial number 1. Okay, that's why you must really spare some time to watch the tutorial number 1 so that you can practice on all the concepts that we have learned so far. Yeah, all right. So now that's it. So this is everything that we need to know. Okay, so let's move on. Okay, so now we are done with all the concepts. So I'll discuss 2 questions, then we are all done with today's lesson. Okay, so I'll discuss on 2 questions. Right, so the first question, this is a past year question from SPM 2011. So this is a real past year question from SPM 2011. Okay, so the question is asking, which statement is correct about exothermic reaction? Okay, which statement is correct about exothermic? So you see the answer, it looks very complicated one. The heat absorbed during bond breaking is more than the heat released during bond formation. The heat absorbed during bond breaking is less than the heat released during bond formation. The heat absorbed during bond breaking is equal to the heat released during bond formation. No heat is absorbed or released during bond breaking and bond formation. So how to do this kind of question? Okay, how to do this kind of question? Okay, So first of all, you need to understand a very simple idea. You must understand this, okay? When you want to break the bond, you always need to absorb the heat. When you want to form the bond, you always need to release the heat. Okay, you need to release the heat. Okay, so these are the two important concepts that you must know. Okay, these are the two important concepts that you must know. Okay, so breaking bond need to absorb the heat, forming bond need to release the heat. So if you look at the four answer here, answer donkey is wrong already. Why? Answer donkey say that no heat is absorbed, no heat is released during bond breaking and bond formation. So this is wrong, right? During bond breaking, you should absorb the heat. During bond formation, we should release the heat. So they say no heat, so it's wrong. Okay, all the chemical reaction, they will involve heat. All chemical reaction got heat. So answer donkey is wrong already. Yeah. So now how to choose answer A, B, and C. A, B, and C. Yeah. All right. So how to choose the answer A, B, and C? The only difference is what? The heat is more, the heat is less, or the heat is equal. Okay, there's only three things here: more, less, or equal. How to choose? Okay, so we can do this question using two methods. We can do this question using two methods. Okay, so I teach you both methods here. So the first method is a simple mathematic method. Okay, it's a mathematic method. Mathematic method. Okay, so they want us, so what we know, exothermic reaction. Okay, so when you are given the bond, when they talk about bond energy, what is the formula we learned just now? Delta H equal to energy to break bond minus energy to form bond, right? True or not? Delta H is the energy to break bond minus the energy to form bond. Okay, so now they want to get exothermic reaction. So exothermic reaction means the delta H must be negative. Am I right? Okay, if you want to get exothermic reaction, the delta H must be negative. So this delta H must be negative. So let's do a mathematic concept. Mathematic concept. Okay, mathematic concept. If you want to get negative answer, okay, if you want to get negative answer, you need to take small value minus a big value. Am I right? You must take something small minus something big. Then only the final answer is negative, isn't it? All right? Because if you take big value minus small value, your final answer should be positive. Okay? So it's a simple mathematic concept. So we need a small value to minus a big value. Then only we will get a negative answer. Why we need a negative answer? Because when the delta H is negative, then only it is exothermic reaction. Okay? So now, if this is small and this is big, so small means what? Less. Okay? Alright? So this is more. So the breaking bond should be less than the forming bond. So the breaking bond should be less than forming bond. So let's look at it. Okay? So the heat absorbed during bond breaking is more. You don't want more, right? You want less. Okay? The heat absorbed during bond breaking is less than the heat released during bond formation. Okay? Because when the bond breaking is less, so means small value minus the bond formation, big value. So small minus big, then only you can get negative answer. Okay, so this is a mathematic method. So the answer is B. So if you don't want to use mathematic method, or if you feel mathematics is too complicated for you, no problem. You can use another method. If you feel that this mathematic method is too hard for you, you can use another method. Okay, you can try to use another method. Okay, so you can do it like this. You can do it like this. you can draw energy profile diagram. Okay, you can go to draw energy profile diagram, okay, for your exothermic. So how to draw energy profile diagram for exothermic? So exothermic, how to start? Exothermic, you start with reactant. Okay, this is reactant, and then you must go for product. So energy, so you will get more energy or less energy when you go for exothermic. So exothermic, the heat is exit, exothermic exit. So when the heat exit, when you release energy, so the energy should become lesser, right? The energy should become lesser, so go down. Okay, so this is product. So this is your energy level diagram. So we can modify the energy level diagram to become energy profile diagram. Huh? So we just remove this arrow. We move this to the right hand side a bit. Okay. And we draw a small mountain. Okay. So this is the energy profile diagram for exothermic. This is the energy profile diagram for exothermic. Okay. So now, once you have this diagram, let's double check again. So the reactant release energy. So this is product. Okay, so the energy is lesser. So lesser is exo lah. Okay. So now, once we have energy profile diagram, so the next thing, now we can figure out the breaking bond and forming bond. Okay. Reactant need to break bond. Okay. So to break bond, you need to absorb energy. Okay. Product, you need to form bond, right? To form bond, you need to release energy. Okay. So absorb is greater or release is greater. So you see who is higher. Reactant is higher than the product, right? Reactant is higher than the product. So when reactant is higher than product, so this energy is more than this one. Okay, so this energy is more than this one. Okay, all right. Okay, all right. Sorry guys, I label wrongly. I label wrongly here. Okay, sorry. Okay, so now we know already. Sorry, I repeat one more time. So left hand side is reactant. Reactant need to break the bond. Right hand side is product. Product need to form the bond. Okay, so how much energy we need to absorb? Okay, so we learned earlier today. So the energy that we need to absorb is here. So the energy that we need to absorb is the gap between reactant to the peak. Okay, so you see, this is the reactant and this is the peak. So this is the energy that we need to break the bond. So at here, so this gap is the energy to break the bond. Okay, so I call it as break. So what about form the bond? Okay, so we learn today the energy that we need to form the bond is this. Okay, so to form the bond, so to form the bond, okay, the total energy released to form the bond is the gap between the peak to the product. Okay, the peak, the highest point to the product is the energy released to form the bond. So you see, this is the highest point and this is the product. So the gap here, so this gap here is actually the the energy released to form the product. Okay, so now which one is greater? So you can see the breaking bond is so little, the forming bond is so much. So the energy that we absorb during bond breaking is lesser than the energy released during bond formation. So it's less. So it's less. So the best answer is B. Okay, the best answer is B. Okay, so I repeat one more time. I repeat one more time just to make sure everyone can see this concept. Okay, so if you want to use the if the question talk about bond breaking, if the question talk about bond forming, okay, so what you can do is that you can do mathematic method. delta H equal to energy to break the bond minus energy to form the bond. So the delta H need to be negative because we want exothermic reaction. So if you want to get negative answer, we need to make sure that we take a small value minus a big value. So this small value is referred to break bond. Okay, the small value is referred to break bond. So break bond need to absorb energy. So when you absorb the heat, okay, so small means what? Lesser. Okay, you absorb the heat lesser than this. Form the bond need to release energy. Okay, so you need to absorb less heat compared to the release heat, so it's less. So the keyword here, less. Okay, so this is the mathematic method. Okay, actually me myself, I prefer to use mathematic method. So if you don't want to use mathematic method, then you can draw the energy profile diagram. So how to draw the energy profile diagram? Okay, so you can start from energy level diagram first. So for exothermic, this is your reactant. So exothermic will release energy. After release energy, energy become lesser, go down. So this is your product. So this is your energy level diagram. You can modify the whole thing to become energy profile diagram. So once you get energy profile diagram, how much is the heat that you absorb? Okay, the heat absorbed to break the bond is here. Reactant to the peak, this is the energy to break the bond. Okay, so how much energy is released to form the bond? So to form the bond is from the peak to the product. So here, this is the form bond. So as you can see, break bond is like this only, form bond is like this. So breaking bond, the energy is less than forming bond. So that's why I choose less here. Okay, so this concept is so important. So that's why labeling is so important here. Okay, when you do the labeling, you must really know how to label it. Okay, all right. So the gap between this one, the highest point, and the reactant, this is the energy that you need to absorb. Okay, so from the highest point to the product, this is the energy that you need to release. Okay, and from the highest point to the reactant, this one also can call activation energy. Okay, so the gap between staircase, this is delta H. Okay, right, so this concept is very important. Make sure you practice and you know how to label. Yeah, we will discuss a few more example. Yeah, we will discuss a few more example, okay, for this kind of question in the next lesson. In the next lesson, we will do tutorial number 1. In tutorial number 1, we will discuss a few more example, okay, so that you can understand the whole concept in a better way. Yeah, all right, so I think that's it. So this is everything that we need to learn in today's lesson. Okay, so in today's lesson, we cover a few concepts. We cover the introductions of the thermochemistry. Okay, so hopefully by now you know already what is endothermic, what is exothermic, and you know what is the temperature change. So for endothermic, temperature will decrease. For exothermic, temperature will increase. This is very important, and you need to know some of the example for endothermic. You need to know the example for endothermic. Okay, example for exothermic, no need to know. Too many examples already. And you need to know the co-pack. In the co-pack, we have ammonium nitrate. We put ammonium nitrate in the co-pack. Okay, and we need to know when you change from one state to the other state, you will involve heat as well. So if that chemical process you need to heat up, so it's endothermic. If that process you need to cool it down, is exothermic. That's it. Okay, and you must know what is thermochemical equation, and you need to know how to use the sign positive and negative to tell whether it's endo or exothermic. By looking at the sign, you should know it's endo or exo. Then we must know how to draw the energy level diagram. Okay, how to draw energy level diagram and how we modify the energy level diagram to become energy profile diagram. Yeah, that's it. And after that, okay, we need to know how to use the bond energy. Okay, before that, we must know 3 important information that we can get from energy level diagram. Okay, so if we are given energy level diagram, we can get 3 information from there. Yeah. So after that, we need to know, all right, we need to know how to calculate the delta H, how to calculate the heat of reaction by using bond energy. Okay, how to use the bond energy to calculate the delta H using this formula. Okay, after that, you must know how to label your energy profile diagram. Okay, so in the energy profile diagram, make sure you know what is your activation energy, where is your delta H. These two are the most important one. Make sure you know how to find out the energy that you need to absorb and how much energy that you need to release. Okay, so that's it. So there are 4 things here. Okay, this is number 1, this is number 2. So energy absorbed is what? From the reactant to the highest point. So this is the energy you absorb. So energy release is what? From the highest point to product. This is energy you release. Okay, so that's it. All right. So it's not very hard, but it can be very confusing. Okay, there are many concepts. It can be a bit confusing lah. Okay, so that's why you should really spare some time to try out the tutorial in the next video lesson. Okay, so I think that's it. This is everything that we need to learn for today's lesson. Okay, I'll see you in the next video then. Yeah.